Hi guys, in this video I'll show you how to calculate the probabilities for binomial and Poisson distributions using Microsoft Excel. So let's say we have a binomial distribution where the number of trials is equal to 10, the probability of success is equal to 0.6, and we need to find probabilities for these values of x. Okay, so we'll use a Microsoft Excel function that's called binomdist, which has 4 arguments. The first one shows the number of success. The second one is the number of trials. The third one is the probability of success. And the fourth one is for determining whether or not you are dealing with cumulative distribution function or probability mass function. So in this case we are trying to find the probability mass function, so we'll put 0 here. Okay. Then what I'm going to do is to freeze these two cells because they are not going to change for my other x values, and hit enter. Then I'll take this formula up until the end and I'll get the probabilities for all the given values of x. For example, this shows the probability of x equal to 7, which is in our case 0.21. And if I want to find the cumulative probabilities, which is actually denoted by probability of x being less than or equal to x, then I'll use the same function with one difference. Here, instead of choosing probability mass function, I'll type 1, which will give me the cumulative distribution function. So here, for example, this number shows the probability of x being less than or equal to 7. Less than or equal to 7. And this number, for example, will show the probability of x being less than or equal to 4. And so on. So here you can see that here the sum of all probabilities is equal to 1. Because what we have here are 11 mutually exclusive and collectively exhaustive events. For the same reason, the probability of x being less or equal to 10 equal to 1. Now I can create the probability distribution graph and see what is its shape. So if I change the probability of success to 0.5, I'll get a distribution function that is absolutely symmetrical. However, if I change the probability of success to lower numbers, closer to 0, I'll get a distribution function that is right skewed. And if I change the probability of success to higher numbers, closer to 1, I'll get a probability distribution that is left skewed. Okay? So now let's do the same calculations for Poisson distribution. So Poisson distribution has only one argument, that's the lambda. So I'll type Poisson dist, and I'll choose my x here, and I'll get my mean, and again I'll put 0 to find the probabilities for exact values. Here I'm going to freeze only the mean. Okay? And I'll drag it to here. So again, this for example shows the probability of x being equal to 7. This is the probability, and so on. If I try to find the cumulative probabilities, let's say probability of x being less or equal to 2, then I'll again type the Poisson dist, where my x is 2, my mean is 7, and now I'll type here 1 because I'm looking for cumulative distribution function. And I'll just freeze this cell and hit enter. So this probability, for example, is the probability of x being less or equal to 8. Okay? So this is how you do the calculations for Poisson distribution. Now let's do two examples, one for binomial distribution, one for Poisson distribution. The first example says that when a consignment of pens arrives at the retailers, 10 of them are tested. The whole batch is returned to the wholesaler if more than one of those selected is found to be faulty. What is the probability that the consignment will be accepted if 2% of the pens are faulty? So, my n, which is the number of trials, is equal to 10, and my probability of success is equal to 0.02. Now I am looking for the probability of x being less than equal to 1, because if the number of defective pens is less than equal to 1, then the whole batch, the whole consignment will be accepted. So here is my 1, and I'll type the binomial, this function here, where my number of success is 1, number of trials is 10, the probability of success is 0.02, and I'm looking for cumulative function. So this is the probability I was looking at. So the probability to accept the whole consignment is equal to 0.98. Now let's have a look at the problem that can be solved by Poisson distribution. The problem says that the number of road construction projects that take place at any one time in a certain city follows a Poisson distribution with a mean of 7. So my lambda is equal to 7. We need to find the probability that more than 4 road construction projects are currently taking place in the city. By looking at probability of x being more than 4. Now this probability is equal to 1 minus probability of x being less or equal to 4. Okay, so I have x is equal to 4, and I'll type here the Poisson distribution, Poisson dist, where my x is 4 and my mean is 7. And I'm looking at cumulative distribution because I'm looking at the probability of x being less or equal to some number. Okay, so this is the probability of x being less than equal to 4. However, to find the probability of x being more than 4, I'll need to subtract from 1 this number. And here is the probability I'm looking at. Thank you very much. I hope you enjoyed it.